Good morning, everyone. I think we're just going to give everybody, well, we're a little bit early here, so 9:57. So we're just going to sit back, relax for a few minutes till everybody's able to join the group here. All right, we're at 10 o'clock now, so we'll give another minute, maybe two max before I get started on the presentation here, just to let everybody join in who's logging in at the moment. Okay, looks like everybody is in. I haven't seen any participants add in the last couple minutes, so I'll go ahead and get started here. My name is Justin Campbell. I'm the general manager at Campbell, and we are autoclave block manufacturers located in Hamilton, Ontario. We've been in business since 1946. The company was started by my grandfather and his wartime buddy, George Day. After the World War, they got back to the city, decided to come up with a business plan. Manufacturing concrete blocks was what they decided on. They started out manufacturing the block in my grandfather's garage during the day. Sorry, at night, they would deliver them during the day. George Day ultimately left the company actually in 1948. At the time, they just printed some new business cards, some new stationery. My grandfather didn't have enough money to reprint, so the name stuck. So George Day's been gone since 48, but still Day and Campbell. You see the picture there of my grandpa and his partner there. That was a different partner that came in the 60s. He exited in the 70s. Harry Sevier, he was also instrumental in the company. Kind of a cool picture here. We got it at the local archives. This is still our original plant. There's been a little bit of modifications to it, but just a really cool picture. You really get to see some of the history, all those old 50s cars out there. And that original sign up there, the Dane Campbell with the block around it, is still the same sign that's up there today. We've done some slight touch-ups to it, but they don't make paint like that anymore. So I'm just gonna show a quick video. It's just gonna really give you an overview of the plant in its current state today. You get to see some of the inventory, things of that nature here. So it's only about a minute long, and jump back in as soon as it's finished. I apologize for the music. Let's just skip over that one. It looks like I'm actually wearing the same shirt as today. So part of that video, you can see we have a fairly large inventory, but you might notice there's a lot of different products out in our yard. And we're able to keep a smaller inventory base and a wider range of different products based off of really our autoclave curing technology. This picture gives you kind of an idea of some of the benefits here. You can see the real color consistency across the board in the product, very uniform from run to run. Again, that really is the reason that is able to happen is because of our autoclave curing system. So a lot of people don't know what autoclave curing is. We are the only autoclave block manufacturer in North America, perhaps the world even. I'm not aware of anybody else that's autoclaving. The technology has been around for a long time. For various reasons, people stopped autoclaving. There was a great cost at one point in autoclaving. It was energy intensive, but we've done a lot of different things to make that autoclave process as efficient as possible. And at this point in time, we actually cycle our autoclaves more economically than we would a traditional low pressure cure. So typically when you manufacture a concrete block, you're going to put those units into a kiln and you're going to mist in some steam, high humidity, temperature conditions, and you'll take that up to somewhere around 120 Fahrenheit is the typical curing point for concrete masonry units. That's just set to an atmospheric pressure, and an autoclave is the opposite. An autoclave is a large pressure vessel, kind of like almost think of a submarine. We use a really unique curing process. So that low pressure cure system would require roughly in between a 10 to 12% cement to aggregate ratio. Whereas an autoclave, we're only running with 5%. So we're using half or even less than half of the cement that a low pressure cured system would use. And we have a separate ingredient, silica flour, that we add into the mix, which acts as the catalyst during the curing process. So some of the advantages right off the start, obviously the reduced carbon, just for the fact that we're using half of the cement. It's a great advantage. The carbon footprint is literally half or less than a low pressure cured unit. Those blocks are lighter and stronger. And they're lighter just for the fact they come out of that autoclave 100% fully cured after just an 8-hour cycle. So that low pressure cured unit, we would need to inventory that after the initial 12-hour curing process. We would need to inventory that in our yard for 28 days before we would be able to ship that product. And that's a CSA standard. Everybody knows concrete, it needs that 28 days to cure. The autoclave units are fully cured in that 8-hour cycle. So what we make today, we could in theory ship out tonight. Again, so going back to that initial discussion point about the inventory and how we can keep some lower numbers, we still do have a large inventory, but if we need to turn product over quickly, we don't have to schedule 28 days out. We can make that happen pretty quick get a mold in, run it, ship it the next morning with no worries, no lot numbers, um, just a tremendous advantage. It also reduces efflorescence, essentially concrete block that are cured in an autoclave. So this is a picture of the autoclave here. You can see that pressure vessel with the locking mechanism. When we pressurize the autoclave, we put it up to 120 psi, which equates to roughly 365 degrees Fahrenheit. It takes us about 4 hours to ramp that pressure up. Then we hold it for 4 hours, and then we exhaust it. And under those conditions, the hydration process rapidly accelerates with that silica flour and that Portland cement. So all of these compounds that promote efflorescence essentially become inert compounds trapped in a crystalline structure. So you really don't get efflorescence on autoclaved masonry units. You may see some efflorescence on an autoclave job. It's typically coming out of the mortar, very superficial, easy to get rid of. Nature will naturally take care of that over the course of time. But you won't see that real heavy. I'm sure everybody has seen it where the block has a big white film down a wall. It's usually, that western facing wall, the north wall that doesn't get as much sunlight. So autoclave block, again, don't get that efflorescence. Because of that 8-hour curing process as well, the linear shrinkage while the concrete cures is all completed in the autoclave. So again, when we low pressure cure a masonry unit, we need to let that sit in our yard for 28 days. So, sometimes those units are still curing up to a year later. The bulk of the curing is definitely done at the 28 days, but there's still room for more shrinkage. Sometimes people perhaps are shipping concrete before the 28 days. The autoclave unit, all that curing is done. So it's not going to shrink anymore. Now in the service environment, as the product absorbs water, say it's raining under construction, concrete will still, like any other material, still expand and contract, but it will do that at 50% less rate than a low pressure cured unit would do. So if we take a dry autoclave block and a dry low pressure cured block and saturate them both with water, the autoclave block will expand 50% less than the low pressure cured unit. So again, big advantage. I've got another slide coming up that'll talk a little bit more about that. But that low moisture content, when the block comes out of the autoclave, it's basically at 0% moisture. So we have tremendous advantages during winter construction primarily, where we've seen competitors' products on site, we've pulled them and tested them, and we've seen units in the winter as high as 70% moisture. Obviously, we want to get a proper uptake with the capillaries in the block and the mortar. And the best way to do that is to have a masonry unit that's dry and cured. So it gives a great suction and uptake, and we get that good bond. And we've seen issues before under winter construction where there was one locally in the GTA where the wall was laid up. They went to grout the wall with a grout pump, and the mortar blew out of the bottom, and the wall actually fell over. So it was a pretty dangerous situation. And the problem they were having was it was cold. They were trying to heat the project, but they weren't able to get the temperature much above 2-3 degrees. And then they had an equilibrium between the mortar and the block. They were both just as wet as one another, so it wasn't bonding properly. Again, an autoclave block, it's going to pull that mortar right up. Of course, we'd still be concerned with freezing conditions for that mortar curing, but they get twice as much production during the winter months with an autoclave unit versus a low pressure cured unit. The block, again, they're lighter in colors based off of that pressurization in the autoclave. We can take a reading at the bottom front and the bottom back. Now these units are 110 feet long, 9 feet in diameter, and the temperature and the humidity is the exact same at every spot in that autoclave due to the pressurization. So what happens at the front happens at the back, and we get great color consistency, so it doesn't look like a checkerboard. This slide is just essentially, again, talking about, lead building is obviously, it's been around for quite a while, and it's not going anywhere. It's getting larger and larger. We're seeing a lot more specs driven with, low carbon products. So again, that autoclave process, just for the fact that we're using half that cement, It's a big win when it comes to lead building. A lot of advantages over low pressure cured concrete masonry units. This slide is basically just talking about the moisture content. I got a little bit ahead of myself talking about this already, but it's just showing how that moisture on a low pressure cured unit at 7 days can be as high as 7%, working its way down. In the month of February, you would inventory that product in your yard for 28 days, but if it's freezing, it's not going to cure too well. You know, at the 35-day mark, they're still sitting in the 55% moisture content. Those blocks aren't curing, frozen together in the cube. So again, you can see the autoclave is just flat along the bottom. They come out dry, they stay dry. They're all palletized, shrink wrapped to keep them dry from the elements while they're being inventoried. So this is just another slide showing those step cracks you see there. I think everybody has seen this on a masonry job some place or another at some point in time. There's various reasons for this. There can be foundation shifts and things of that nature, depending if the mortar was mixed too wet or not. But sometimes it does happen from the masonry unit still curing and the mortar is curing and they're pulling each other apart. Again, that autoclave block is done curing, so you're not going to have that shrinkage and breaking that bond with the mortar. So a lot less step cracking in autoclave units. I'm just going to get into some of our modern masonry architectural lines. So we do not autoclave all of our units. We do still low pressure cure some of our colors. And the reason is the pigments aren't heat stable in those autoclave conditions. So the temperature is the issue. We get up to that 300 Fahrenheit. Some of the pigments start changing colors. We are working on autoclaving more of our product line. Eventually the goal is to autoclave all of our colors. But yeah, we do still low pressure cure some of our units. And in that modern masonry line, we make a whole different array of faces, shapes, sizes. So all the standard block you can think of, we can make any of those units in our modern masonry architectural line. So that line encompasses different finishes, different colors. We do have some other different formats that aren't shown here, but this was just to kind of give you an idea that we can process any of these units with essentially any of our finishes. So this background picture here is one of our more lead-friendly block. It's basically 35% post-consumer recycled glass in there, and we are able to do that based off of, again, the autoclave technology. We would not be able to put that glass in there under a low-pressure cured system. So here are the main options available in the modern masonry line. We're trying to show all these in the same format. Again, all of these are available. They go from brick size up to 12 by 24, but for sake of consistency here, we're showing everything in an 8 by 16 face. So we have the standard smooth face, just a standard color masonry unit, which is seeming to make a big comeback with a lot of the contemporary build going on out there. We have our ground face masonry units. So essentially like a saw cut finish. It's a little bit more burnished than a saw cut finish, but it is still a real matte finish exposing the aggregate. Then we go a step further to a hone finish. And this is where we really differentiate ourselves from our competition. We're the only manufacturers in Canada that are able to hone and polish masonry units. We invented the technology ourselves about 10 years ago. We had some proprietary equipment at the time made. So the hone face finish is similar to a ground face finish, but we're taking it a step further and we're putting a semi-polish onto the face. That semi-polish really separates itself from that ground face where you still see the aggregate, but it's a much cleaner finish. That as we get into the hone and polish, it starts bringing out more of the color, which you'll see in another slide coming up. Then we have the polish phase. So we build the polish right up, essentially similar to a granite countertop. It's more like a mirrored finish. So the hone finish is a gloss finish, but the polish is more of a reflection. You can move the unit around when you have a sample face and actually see a reflection, the lights on the ceiling. Then we've got the standard old split face. We make a shadow finish where we grind the top and the bottom. We leave a raised section in the middle, which could be smooth, ground, honed, or polished. gives it an alternating coursing look. The reason for that, it gives it a bit of a three-dimensional look on the wall, and at the same time, where the mason's not laying multiple small units, so get better production on the install. Really cool block. It's a very unique look too. We still have fluted split face. We have scored units, again, same thing, so we can take any of those smooth, ground, honed, polished. We can score it vertically or horizontally. We're working on a big project right now out in Alberta with the scored face finish. And again, it was a production issue. They had specified ashlars. The project was over budget. We added in the horizontal scored on the unit, and it drastically brought the price of the project down. A lot less units required, and the install cost is going to be much quicker. We've got an antique finish, similar to the ground face finish, where we're texturing the face, kind of like an exposed aggregate, only not quite as aggressive. And then we have the ice finish, which we take that antique finish and build a polish on it. So it almost looks like rippled ice. Another kind of really unique, cool finish. Last one on here is the Tylon face. So we take an autoclaved masonry unit. Again, we wouldn't be able to do this without the autoclave technology. And we adhere a natural stone slip with some of the most advanced construction adhesive technology available. So you get a concrete block, all the benefits of that block, the fire rating, the structure, with the natural stone look to it at a fraction of the cost. We all know how expensive natural stone is. This is just basically showing some more sizing where we can make them in solids, ashlar height, these large formats, so 4x24s, 8x24s, 12x24s. We can bullnose, custom bullnose any corner on the unit. So we can make column blocks, single bullnose, double bullnose, whatever it is. We can add that finish to it. We also make a Custa wall. We can add any of the finishes to those products as well. That's a sound absorbing unit that is typically used in gymnasiums and rec centers. So here's just some pictures here of, this is just a honed finish of a project in Armories building that we did out in Halifax. Again, some polished units here. We did at a private school here in Hamilton. Now, this slide really gives a good indication and a good idea of how those different finishes make each block look. So all four of these are made out of the same block. They all start with that smooth finish. You can see what happens when we ground face it. Again, that matte finish, it kind of dulls the unit out a bit. It's a nice look, again, real contemporary. And you don't see a lot of the natural aggregate and its physical properties when we do that ground face. But when we go to that hone finish in the top right, it really starts bringing out the color and the true, the grain in that aggregate. You can start seeing more fleck in the aggregate. The color gets a lot richer. When we go to the polish, it even pops out more of that color. So it's hard to believe all three of those finishes there come from that smooth, but they all offer a very unique, different finish. So kind of cool. It's mostly noticeable on the darker products. When we get into the white products, there isn't such a drastic change. You can only make white so white, it doesn't get brighter, but you do see more of the aggregate in there, and you also get that reflection off of the product. We have sample boards available. We just actually retooled our sample boards, and unfortunately I didn't finish getting all of the units cut. So we have, some of them are missing on some of these sample boards here, but this is something that you could request for your office. And we also have all of these photographs in a high resolution swatch, which works great. You can email us. It's the first time that we've truly been able to capture the true color and get an accurate photograph of what these products look like. In the past, the picture was always a little bit off, the color. We really got it dialed in on this one. The company we hired did a spectacular job. And it's a great starting point if you're ever looking for, we're looking at these 5 colors. We can email you those. You can have a better look, blow it up on the screen. based off of those finishes, you could narrow it down perhaps to say, send us 2 of these face cuts. We can cut those faces to different sizes depending on what you're looking for, and get those samples out to you right away. So again, you can see the difference. A lot of the same product on these boards, but completely different with the 3 finishes there. 4 finishes, I should say. All of the custom orders that we make, so we don't inventory those colors in all of those finishes. We do have lots of odds and ends left over from projects, but we make every run custom made to assure ourselves of color consistency, making sure the aggregates, we could get into a different blast in a quarry. So we want to make sure everything is made to order. And again, with that autoclave technology, we're able to turn these orders over usually fairly quickly. Max really would be an 8-week typically layout, but we're turning products around a lot quicker than that. A lot of times we're doing 2 to 4 weeks is kind of the standard where we try to keep lead times at. So the products all get wrapped, labeled out in the yard. Just some more job shots here. This is a project we did in Quebec, and we do have distribution in every province across the country. This one was a fairgrounds in Quebec. That's an ashlar height. That was the black polish, so you can really see that reflective finish. The job turned out really well. Mason did a nice job as well. This is a Copley suit, the company that makes suits, Copley in Hamilton here, so not too far from our plant. They went with a polished, so you can see this over here. That's not blemish. It's actually a reflection of the sky, the clouds. The finish there, you get a good idea of the polish. That was a full polish on that project. We've done large scale projects. I think we put 80,000 units into the Tim Hortons field in Hamilton here. This was a ground face finish job just to kind of show, we did, I think we ended up doing 5 different colors on this project. This one was in Quebec as well. Architect got a really unique design. Mason did an outstanding job. I wouldn't want to be the laborer running the saw on this particular project, but give you an idea of the color consistencies. Again, this project here was a private school in Hamilton. This is one of the first polish projects we did. We did in 2 phases. Again, we put about 80,000 polish units into this school. They went with basically an ashlar kick plate there with our cameo white colors. So both these were standard colors too. So no premium on the color pricing. We bullnosed all the corners in the school. They did a nice stack bond with a rake joint. Probably our best job still to date. I wish I could have got a picture during the daytime when the sun is coming down the hall. Just beautiful. You can see that reflection. They polished the floor as well. More ground face units here. Done large scale community centers, Meadowvale with a ground face finish here. Just outside of Toronto in Mississauga. We do a lot of schools. This is a ground face finish, again, clack. This is funny. After we did that first school that I showed you the pictures of, we took the architect through there. He wanted to see the product. He had already specified it on his school, and we took him through that school 2 days before we were starting the it was 1 day before we were starting the manufacture of their order. He liked the color scheme of that school so much, he actually copied it. So we had to pull a pretty big audible and change up the production, but came out really well again. Standard ground face on a residential unit, just split face and Saskatchewan, just the white standard old split face. These are the Coustawall units. Sure some of you in the Ottawa market are familiar. It was Dane Campbell and Permacon at the time were the only 2 offering this style of a Coustawall unit. So we've done just literally hundreds of gyms and rec centers across the country. So it's got a fibrous filler inside of that unit that we stuff in the factory. It's palletized, so the mason just needs to pick it up, install it like a normal block. We can help with different design. We've got all kinds of technical literature on square footage and how to come up with that specific amount of Acoustawall for the project. And we can apply any of those finishes to this product. We've done it in a polished super white. We've done it in smooth colors. So Lots of different options there. This is our newest product, the OmniBlock. It is a licensed product out of the United States. So we bought the Canadian rights to manufacture and distribute this product. And we all know how building code is changing. There's a much larger push towards energy efficiency. Again, that's as building codes evolve and change, that's just going to become more and more important. These higher R value requirements are difficult to meet with ending up with a giant wall assembly, which becomes very costly, eating up some of the footprint of the building. So OmniBlock is a concrete masonry unit, still meets all the CSA 165 requirements, except we are adding in this expanded polystyrene insert into the unit. So we make it in two different sizes. There's an 8-inch, there's an 8-inch unit and a 12-inch unit. So this is the 8-inch unit standing up here. You can see there is still the cross web connecting. So it does have some slight thermal bridging, which has been greatly offset by those web thicknesses being half high and moved over to the middle. So we have a short insert that goes on the interior and a long insert on the left side that would go on to the exterior side. So again, you get all those benefits of the fire rating and the structure with a single trade install. So when we talk about R value, initially when we got the technology and some of the technical information from the States, we started going out, taking it to market, and we realized that the disconnect when it comes down to effective R value versus calculated R values. And there's a lot of misconception out there, and people really don't have a great understanding of these different R values and how they came to those numbers. So we ended up hiring a company called RDH Building Science. They're in the Kitchener-Waterloo area. These guys are real leaders in building science. We had them break down the whole product again, do some thermal modeling on it, and come up with true effective R values. So an 8-inch OmniBlock, initially, it was advertised at an R20. So we're taking the thicknesses of all of the expanded polystyrene, adding that up, getting that R20. Well, that's not the true effective R value. Most people do it that way. Most companies do it that way. The number looks better, but in theory, it's not the case. So the 8-inch we're showing here has an R value of 9 effective, and the 12-inch has an effective R value of 13. We did this in the most stringent way possible with the thermal modeling. We wanted it to be, worst case scenario for the product. You can see when we start grouting cores, we do lose some of that R value. But this next slide is a real eye opener here. So a lot of people are saying, well, I can go with an R20 insulated batt wall with steel studs, and you guys are only R9, they're R20. Not really. So RDH had done some thermal modeling on a steel stud wall with R20 batt insulation. And it turns out when you get the whole assembly built, do the proper thermal modeling like we did, an R20 insulation wall is actually only R7 effective R value. So a lot of the times the product is not even meeting the code. So when we say we're R9, we're actually ahead of this steel studded our assembly. So we do have another presentation specifically to OmniBlock. I could probably spend an hour and a half on this. So I'm just going over some of the key points just so everybody can get their head wrapped around how we're out there designing our product. This is a 8-inch OmniBlock wall assembly here with thermally broken ties with a brick wall. So there's an air film and an interior air film on the wall. Every wall would have this, that would give you a 0.6. We've got an aggressively grouted, so every other core, which isn't typical, but aggressively grouted OmniBlock system at 5.4. We get 0.97 out of the 1-inch airspace, 0.39 out of the brick, 0.17, which would give us an R7.6. So again, that would still be higher than that steel stud R20 batt insulation wall assembly. Now we can do different things with that assembly. We can also add some rigid insulation, some rock sol, or we can fur out an insulate the interior of the wall. So there's a lot of different ways to get to the desired R value depending on the type of building that you're building. Again, this is the 12-inch masonry unit. So I know, again, out in, let's say Winnipeg, they require a much higher R value than we do here in Ontario. And they're looking for wall assemblies that are R25. An effective wall assembly at R25 gets pretty thick. Massive footings, it really doesn't seem cost effective. So you're able to get that R13 out of the Omni block and still keep your same assembly thickness that you're using today to achieve that R25. This assembly is not showing that, but this is taking up to an R15, which works in Ontario for a variety of different applications. Again, no added insulation, single trade install. This is an excerpt from our Omni block guide here. This guide was designed by RDH Building Science, and we came up with a whole different pile of configurations to help the design professional. So basically, you can go off of the code book, and it kind of breaks down into what R value you would require for your specific project. And then this guide shows you different ways to get there. So this particular one at the top here, it's showing an 8-inch Omni block stretcher. So then we're looking at, okay, we are going to add, we needed R13.6. So we find that R13.6 using Z-girts. We could look using metal clips or the thermally broken fiberglass reinforced clips. I would look over here at my grouting. Okay, this is one of 3 cores grouted. So we have the mineral wool, we have the closed cell, the expanded polystyrene, so rigid board or closed cell spray foam for additional insulation. And we could look, so an 8-inch Omni block wall with 1 inch of closed spray foam utilizing say Z-girts, depending on what variety of substrate you were using as a veneer. You could get an R12, you would add 2-inch, you would get to an R14.5. So the guide is really simple to use once you get an idea of it. I think it's about 60 pages of different information, design guides, but it's a really great tool, really simple to find where you need, what you need, and how to achieve that with different options. And then you can start crunching the numbers and look at, which one's the most cost effective versus aesthetics. So again, on this Omni block, we could apply any of those finishes on the inside, and the unit would be completed right after the install. So this is a 12-inch block wall here. You can see, so there's up here, we've got some rebar for the grouting. You can see how the inserts go in. Those inserts really do not add very little time to the project. Most of the masons said it's no different. The labor just walks down to the bag. After the course is laid up, you can drop those in really quickly and move on. This is a split face project we did. We're doing a lot of warehousing. This one, I can't remember exactly where it was, but again, a split face. I think they were going with some steel on the top, but they needed masonry on the bottom. They wanted something durable, robust. Omni block worked perfect for that. This was a large community center we did. So this is all Omni block here. There's a swimming pool. This is the exterior of it. So you can see where they clad a portion of it with some natural looking stone there. Can't remember how they finished the top, but this one's a ground face unit. This is all Omni block again, a self-storage unit. Some more Omni block. This one, I believe, I can't remember if it was a honed finish. We did a fire station in Mississauga. So we've done a couple fire halls with it recently. Lends itself really well to those types of projects. It is really big in the States. They do a ton of residential in it in the warmer climates. There's literally been tens of thousands of homes built in Arizona and Florida with it. We've done some basements up here in Canada, but we have not gotten into the residential side of it yet, but great product. Last one I'm going to show you here is the tile-on masonry units. So you can see the 8-inch concrete block with the tile adhered to it. We make it in an 8x16 face. So that can be on any depth, 10 centimeter up to a 30 centimeter unit. And then we make a 12 by 24 as well. So we have various colors. We have a flawless white marble. We have a black granite in a flamed and a polish. We have a gray granite, different finishes. This, you can see what it looks like after it's installed. So again, you've got that. These are large format units, so these are veneered, but the price per square foot was literally half of what the natural stone was. Nobody knows the difference. You've got that true calibrated natural stone slip on that. We've got those tight tolerances on the masonry unit. So the mason would just lay this up just like a normal masonry unit, get that natural stone finish to it. That's basically all that I have at this point in time. So if there are any questions, I'd be more than happy to answer those.
We haven't had any questions come in the Q&A yet, but if you guys have any questions, just throw them in the Q&A and we can read them out to Justin.
Making my job real easy here.
Yeah, you did a good job.
So yeah, if anybody thinks of anything or they want to request any literature, any samples, again, we do have a full presentation on the Omni block that gets a little more in depth into it. Feel free to reach out. We've got our booth in the exhibitor floor there. You can click on that booth. There's a bit more literature in there. And you can submit any questions or requests through there and we'd be happy to help you out.
All right then.
Okay, excellent.
Thank you so much, Justin. Thanks to Dan Campbell. Great presentation.
Appreciate it.
We'll see you guys at the next one.
Thank you, everybody, for your time. Enjoy the show. Take care.